Hello all, in today's class we are discussing about inherited attribute example. So which is a example for inherited attribute and which makes use of top-down approach. The synthesized attribute was using a bottom-up approach. So we have to first construct the tree which make us to easy the construction of SDD. Okay, semantic rules can be constructed easily after a parse tree. Okay, so let us understand how exactly annotated parse tree is being constructed for a given production. So this is what our given production. This is also a desktop calculator with simple only multiplication is allowed here, and which is not having left recursion over here. But previous example was there was a left recursion over there. Since it was a bottom up, it was allowed, but for top down approach we already know that left recursion grammars are not allowed. So you have to remove left recursion, then you obtain this kind of productions. Now we have to construct annotated parse tree for the simple expression 3 star 5. Okay, so we'll start doing it, and we know that for top down approach we start from T produce ft dash ft dash, then f produce digit because I want 3 to be generated, so only digit is been constructed, and t dash is producing star ft dash star ft dash, then this f is producing only digit, so digit. Similarly t dash producing as per this epsilon, so only this much has been constructed. Afterwards we will start annotating our parse tree. So already we know that all leaf nodes are synthesized attributes. So dot lexval is retrieving the value 3 from the symbol table. Similarly dot lexval is producing 5. You have to generate them. Then afterwards, according to this statement, it is just synthesized attribute. A digit value is assigned to f. Therefore, this value to be moved up. So it is becoming f dot val is 3. So after doing this, this node for computing the value, this node, since it is having a binary operator star, it always requires operand towards left, one operand, towards right, another operand. There is an operand here in the right side, but it is not having a left side operand. So for that reason, what it does is it asks this node to get the value from the sibling. So value obtained from the sibling is being borrowed. That's why the attribute of this is called as a inherited attribute. Look at this. You have to label them according to the nature of the attribute. Since it is a synthesized, we are directly writing a value, but this value is not a value, just it is an inherited value. So mention that inherited. So for this you are assigning 3. Now afterwards, this operator requires this value as well as this value. So it takes a value from the parent, and from this node is going to obtain this value and this value together. Then it is going to compute the value as per the law. So what is that rule to be used here? Since it is a multiplication, 3 star 5 is being computed and assigned here. So this node is borrowing one value from the parent and one value from the sibling. Therefore it is again inherited. So dot inherited is 15. So how did we obtain this 5 value? It's same as this procedure. So we obtain its value from the child, that is 5. It is a synthesized value, so dot value we call it as. So once this computation is done, as per the rule, since there is a production called t produce epsilon or t dash produce epsilon, so because of the epsilon production, inherited value is converted into a synthesized value, because it is its own value because of the, it's becoming own value because of the epsilon production. So give this value to this node and call it as synthesized attribute. It got 15 now, and this value is moved up here, and t dash synthesized becomes 15, and this value is going to up, and t dot value is becoming 15 now. So though it is a bottom up approach, you have to move all the values to the root and print it on the screen. So for that you are sending all the values to the root node. So this is what explanation for inherited attribute. So after doing this construction of the annotated parse tree, you have to write this syntax directed definitions. So let me clear all this. So how do we write this? Very simple. Wherever synthesized is there, directly write that f produce digit is a synthesized attribute. Digit dot lex val has been assigned to f dot val. Next, moving on to next one. This is because of this, what is happening here is inherited attribute is been converted into synthesized attribute. So moving on to next production, that is t dash produce star ft dash. Actually if you look at this, it is not t dash, it is not a new node here. T produce ft is a production actually. So in the tree, this place of this t is different from this t. So just to make a difference between them, because this t is different from this t, we are introducing additional notation called dash. Okay, it's not a new non-terminal t dash, it is same as this t as per the production, but in the tree, the level of tree is the level of this t is different from this tree node. So that's why we are using t dash here. Okay, next moving on to this particular part. So we see here, if you just look at this production and go to the tree, look at this particular tree, subtree in the parse tree, then what are the rules were applied there, check it out. So this is the only one rule which we applied. That means we are doing some computation with star, and that synthesized value has been moved up. So only these two actions which we are performing. That means this is what our production. So in this, computation of this value has been done. Similarly, the synthesized value has been moved up to this. Okay, so only two actions. That's why we are listing those two under this particular production. Now moving on to last production, t produce ft dash. So where t produce ft dash in the tree, that means this one, t produce ft dash is only this much subtree, you have to look into that. So what are the actions that you are performing? You are taking value from the left to right sibling, that is the one action, and this value is moved up, that is another action. So only two actions, this one and this value you are moving. That's why you are listing them as a action over there. So moving the value to parent and taking inherited value, f dot value is being considered as a value for t, that's why it is a inherited at. So like this you are listing out all the actions, required actions, along with the productions after writing the annotation parse tree. Okay, so moving on to another example, 1 star, 2 star, 3. So this parse tree, first construct the tree. So t produce f produce digit t dash, only this much, right? Only this much, only this much, digit and this. Now afterwards we know that we have to compute the value. Dot lex val is equal to 1, and this value is moved up, and this value is borrowed from the sibling, so inherited value. Next, this value is computed and moved to this node. Similarly, this value is computed and moved to this node. Okay, Next, for computation of the node, this value which requires two values, the operator called star, and this two values. By considering these two, 1 into 2 becomes 2, and this value is coming down here, it's coming down, and for that operator is again star, so 2 star 3 has been computed and it is becoming 6 now. Because of the epsilon production, this inherited value is converted into synthesized value, and this synthesized value, once it becomes a synthesized value, always it moves up. So this is what a synthesized value which you are moving up, and again this value is moved up, and this value again moved to root node. Okay, the answer is 6. This is how you are constructing the annotated parse tree along by making use of a semantic rules. This completes the whole problem. Thank you.